Okay, in this video we're going to do an example from homework 2 on electric potential energy. So remember that energy is a scalar, right? So direction does not matter. We're just going to figure out the energy that is associated with each of these points relative to one another and then add them all together. So the electric potential energy, the question says you have a charge located on the origin that's 3 times 10 to the negative 9th, and then 0.3 meters away you have a charge that is 6 times 10 to the negative 9th, and then you place a charge that is 4 times 10 to the negative 9th coulombs at another 0.3 meters away. Okay, so all we need to do is we need to calculate the potential energy of each one of these points relative to each other and sum them all together. So we have the potential energy of like 1 and 2 associated with one another. And remember that the equation is KQQ over R, right? So KQQ over R, right? So K is 9 times 10 to the 9th, and then you've got 3 times 10 to the negative 9th times 6 times 10 to the negative 9th all over 0.3, okay? And if you plug these in, I've already had them calculated here, so this video goes a little bit quicker. So I've got 540 times 10 to the negative 9th, okay? Now I'm going to do 0.2 and 0.3. So the potential energy of 2 on 3 is going to be equal to 9 times 10 to the 9th times, so charge 2 and charge 3, so 6 times 10 to the negative 9th, times 4 times 10 to the negative 9th, and those are 0.3 away, okay? And for that, I get 720 times 10 to the negative 9th. And then the last one I'm going to do is 1 and 3. So PE of 1 and 3 is 9 times 10 to the 9th, all times 3 times 10 to the negative 9th, times 4 times 10 to the negative 9th, all over 0.6, okay? And this is 180 times 10 to the negative 9th, okay? Then I'm just going to add all those together, this plus this, and I actually get, after, you know, writing correct scientific notation, I get 1.44 times 10 to the negative 7th joules of potential energy. Okay, now for part B it says, okay, well you take let's say you take this 4 times 10 to the negative 9th charge and you move it 0.6 meters below the origin. So instead of having it up here 0.6 meters, now it's 0.6 meters below, so there's a different energy associated with now them being a different distance apart. Okay, now 0.1 and 0.2 are still the same distance and the same magnitude of charge, right? So I've already calculated that. So the potential energy of 1 and 2 is still the same. It's 540 times 10 to the negative 9th joules. Now, 0.1 and 0.3, even though now they're in a different orientation, they're still the same magnitude of charge and the same distance apart. So 2 and 3 is still 180 times 10 to the negative 9th joules. So really, I only have to calculate one new potential energy, and that is this one relative to this one. So it would be potential energy of, actually, sorry, this is 1 on 3. Okay, this would be 2 on 3. Okay, so 9 times 10 to the 9th times 6 times 10 to the negative 9th times 4 times 10 to the negative 9th, and now they're a total of 0.9 meters apart. Okay, and that actually gives me 240 times 10 to the negative 9th joules. And now I just add these all together again, and now instead of 1.44 times 10 to the negative 7th, I've got 9.6 times 10 to the negative 7th joules.